In problem number 7, we're asked to identify which are not examples of perfect cubes. So let's talk about a perfect cube. We are able to achieve these numbers by going 1 times 1 times 1, or 1 cubed, 2 times 2 times 2, or 2 cubed, 3 cubed, 4 cubed, 5 cubed. I would definitely have these down prior to the test. Remember, it is a time test, and this will help you. So, do we see an 8? Sure do. Do we see a 27? We sure do. Do I have something that has the exponent on the variable is a multiple of 3? Yep, it doesn't matter if it's addition or subtraction, because remember, it's the sum or difference. You can have adding or subtracting, and you could still factor this. Okay? So this is an example of a perfect cube. So I'm going to cross it off because it says which ones are not. Is 25 here? 125, yes. Is 1 here? It sure is. Again, sum or difference, either one works. And this is a multiple of 3. Good. Now, I don't see 2 here, and I don't see 16. But remember, you always have to start by asking yourself, is there a number I can factor out? So you start with the smaller number. So 2, can I divide here both by 2? Yep. 2 times 1 is 2. Attach the x cubed. 2 times negative 8 is negative 16. Now, in this portion, is 1 listed? Yes. Is 8 listed? Yes. Is the exponent on the variable a multiple of 3? And remember, it doesn't matter if it's addition or subtraction. So this is an example of a perfect cube. Do we see 64? Yes. Do we see 99? No. So now I'm going to pull out the smaller number, which happens to be 64, and explain using a calculator how I would do this. So I know 99. I can't go 99 divided by 64 and get a nice answer, but I'm going to show you anyways. It doesn't give me a nice answer. So then I'm like, okay, what's the next multiple of 64? Well, 32 goes into it. And I'll show you how 32 does not go nicely into 99. It doesn't work. And the next multiple is 16. So I divide by 16. I divide by 16. I'm taking factors of 64. So 64, 32 goes into it, 16 goes into it. Does 12, I just want to make sure, does 12 go into it? Nope. 8 goes into it, 4 goes into it, 2 goes in. So I'm checking all of these. These are the numbers I'm checking to see, do they go into 99, so I can somehow break this down just like I broke down C. Okay, and you start with the smaller number to do this. So again, I'm going to go back here. 99 does not work with 64. 99 does not work with 32. You don't want a decimal. 99 does not work with 16. 99 does not work with 8. 99 does not work with 4. 99 does not work with 2. And factoring out of 1 does nothing. So I can't factor anything out of this. And even though 64 is here, and even though this is a multiple of 3, and I have, again, adding or subtracting, because this number is not a perfect cube, this will not factor down. It's not a perfect cube. I can't do sum or difference of cubes. Here we go, this one. So I don't see 3, and I don't see 375. So then I'm going with the smaller number. 3. What goes into 3? Factors of 3 are 3 and 1. So let's take 375. And when we divide it by 3, I get 125. So I factor out of 3. 3 times 1 is 3. Attach the x cubed. And 3 times 125 is 375. Do I see a 1? Yes. Do I see a 125? Yes. And again, it doesn't matter if it's adding or subtracting, and this is a multiple of 3. That means I could factor that. That would be a sum or difference of cubes. And again, this problem says which are not. Which ones are not? So 64 and 216. I don't see 216. Oh, I do see 216, and I see 64. Oh, okay, that's great. But remember, if you were factoring this, here's my 64s. Okay, I already had show factor, 32, 16. So I'm going to start with 64. Does 216, just to show you an example here, does 216 divide by 64? It does not. Then does 216 divide by 16? Nope, it doesn't. Does 216 divide by 8? It does, 27. So I can divide by 8. So if you were factoring this, you'd first want to factor out an 8. 8 times 8 is 64. Attach the x cubed. And I just learned that 8 times 27 is 216. And then I can see 8 is here, and I can see 27 is here, multiple of 3 and plus. Now you may be asking yourself, like, why did you do that? Because 16 is already here and 216 is already here. That's true. So the answer already was yes, that this could be the sum or difference of cubes. I just wanted to give you an example of if you were asked to actually factor this, that if you didn't factor out that 8, you would not be completely factoring this. Just to show you an example here, again, how do we do this? This is x, x, x. Remember, always 2 and always 3. This is always a plus sign. So this particular problem had a plus first, so I bring down the plus. This is always going to be opposite. So I take a 2 and an x from in front and a 3 from the back. In this position, I have 2 2's left. 2 times 2 is 4. I have 2 x's left. X times x is x squared. And the back, 3 times 3 is 9. Now, how do I figure out this? Forget about the signs. 2x times 3 is 6x. This would be fully factored if they asked you to do that.